Okay, 13th week, digital design and presentation. That's the topic for today. Okay, as you know, in this semester we have been walked through CAD and graphics as an updated class from digital introduction to digital design and computing. In other words, introductory course to design computing. So, in today's course, I like to put an emphasis again you to realize that this class is something about fishing, not fishes. The term fishy here means AutoCAD, SketchUp, 3D Max, Revit, certain type of application you can learn by yourself, okay? Instead, you have strongly encouraged to teach yourself for any type of complicated software applications. For what? For design, okay? That's why I call the class design computing. Anyway, design computing course, in this course, today we are going to deal with lab exercises, intensive lab exercise with individual meeting, project by project, for developing your final project, okay? Not based upon what? Based upon the lab exercises we have been walked through. And next week, we're gonna review what you have done for the last week's exam, okay? I've got exam result and review, and I'll let you know the score and something else related. Anyway, list up what to do today, okay? Developing your final project using given applications. We have been walked through individual application, even if not 100%, even if I didn't give you any A to Z detailed guideline, we walk through 2D and 3D computer graphics and representations for design computing. So that's the topic for lab exercise. Let's quickly review final project again. I list up this single page again, and I highlighted some specific parts, okay? CAD plans, okay? Usually you're gonna draw outlines. Probably you are working on drawing external wall lines, some outline views using AutoCAD without any specific consideration regarding dimension and scale, human scale. But hopefully you should remember the question last week in the midterm exam, how your plans, how your drawings can be looking professional. Two main keywords, okay? Scale and dimension. That's what your, whatever your drawing is, it's going to be looking professional, okay? Something different from layman's drawing. Anyway, and then make them 3D using, in this case, in this semester, we're gonna use SketchUp. And also render by V-Ray or generate various types of visualizations using styles, screenshots, and so on, okay? And then you can get the images for retouching by Photoshop for additional design visualizations, and prep your final presentation slides, final presentation material using PowerPoint, Prets, or even any other applications you need. Post them, entire your material you created, okay, on top of your Google site, and make a link and present, submit for the final. 2 weeks left, okay? 3 minutes oral presentation in spoken English going to be recorded, okay? Digital design presentation using PowerPoint, Prets, panel, Google site, or others. Anyway, that's we are going to do at the final presentation. Here I list up again, total 8 subjects for your final, okay? So today, project by project review scheduled in the lab exercise hours intensively. Okay, I like to show you a brief slides to explain you what this final project means, okay, using a metaphor, a puzzle metaphor, okay? Simply try to find out missing parts by yourself, okay? What's the missing part? For the final presentation, I gave you a puzzle, okay? I gave you a puzzle. You should make it, even without A to Z guideline. What is A to Z guideline means? A, B, C, D. So you are very familiar with some instructions, very kind instruction, okay? For example, A, open SketchUp. B, click file. C, mouse over, open file, and browse, blah, blah. A, B, C, D, E, F, Z. A, B, C, D, E, F. A, B, C, D, E, F. E, F what? G, okay, E, F, G. Not this G. Okay, anyway, that kind of very kind ABC guidelines, there is no such things, okay, in our university, in Hanyang University. In this class, in this level of courses, okay, you have to find out by yourself. In other words, I'm going to tell you A, D, G, H, J, L, X. That's it, okay? Missing parts, for example, B, C, D, I, J, K, L, all those things supposed to be found by you, okay? Based upon your struggle, Googling, train by yourself, okay? Also, I gave you lots of tutorials, lab exercise cases, examples, and some use scenarios, and so on, okay? You should make it. Sometimes, okay, there are no perfect keys, okay? There are no perfect keys. This is something different from a usual puzzle, okay? There are millions of keys you can resolve. I think this is your current situation, okay? Current status, okay? You screw it up and you don't know what to do, how to resolve, but that's okay, okay? But at the end, anyway, you have to find out your way in a very creative way. Take a look. Sometimes you don't need to find out some typical, conventional key set, okay? You can make it in a creative way. Sometimes you also can find out hidden details, okay, like this. Something usually missing by general people. But you have to train and you open your eyes in order to capture something can be missing by general people, okay? That's the perspective, that's the eye of someone who's studying designs, okay? Anyway, and also you can resolve it in a very unique way. Take a look, this puzzle is not 2D, it's 3D, okay? So there are possibly something really different and unique methods still undeveloped, okay, undiscovered. That's exactly what you have to find out, okay? For doing that, find out your own way, okay? Find out on your way. Practically and specifically say, right now you are working on SketchUp 3D modeling. You don't know how to map your pictures on the surface of the wall. You don't know how to import, how to transform your file format to older version file format, or you don't know what happened. Sometimes your computer shows blue screens or something freeze. But anyway, such experience is going to be your asset, okay, for developing your design skills, techniques, whatever it is, okay? Not just fishes, okay? Fishing, that's the point. Okay, let me quickly show you one of your design presentation examples. Actually, graduation exhibition, exhibit work, exhibit class, that's not the end of your final syllabus in our department. Actually, it's not the final, but anyway, it is one good objective in terms of design representation. I'm not talking about design itself, okay? I like to show you some final outputs from long efforts of design and design development. Take a look, this one. All those pictures taken by me last fall, okay? 2005, September. Okay, take a look. To produce this kind of mock-up model, sometimes they spend lots of time for making totally by hand, but something totally created by digital fabrication, computers, okay? Laser cut, 3D printing, or some other CNC or computer-generated methods, okay? For example, take a look. This one, of course, floor plan, okay? But actually, this floor plan produced by laser, okay? Laser cut. Sometimes laser cut can cut as it literally means, but sometimes make some scars, okay, on the surface of metal or surface of plastic, wood, and so on, okay? By using such techniques, such computing, what you need to prepare is vector, line stroke, line drawings, drawn by SketchUp, AutoCAD, 3D Max, Revit, whatever it is. Anyway, your visualization going to be produced in this way, using totally different material. In this case, metal plate, okay? And also more examples, more cases, laser cut objects, and take a look. 3D printing furniture and the structure of the chair. Actually, I'm not talking about all those very elaborated and very fine-grained production from digital fabrication. I'm not talking about that issues. I just want to show you examples, okay? And also this one, printed out, okay? And take a look. Something wired, okay, based upon the structure here. And take a look. The structure here, looking some freeform or organic shape, also printed out by using this machine, okay, our 3D printer. So, but actually this is quite big size. It's not, it couldn't be printed out just once. Separated, okay, 3-4 parts separated and assembled after printing, okay. That's how you get the bigger size printout products. And also take a look at this furniture, okay. This one, filament material used white one, and in this case, gray colored one, okay. Also 3D printer produced furniture marker model. And take a look, this wall structure, laser cut wood structure, okay, totally computer controlled. There's some more examples. Laser cut, okay, in 2D section, and laser cut typography. Take a look, this contour, usually you use your knife for making this kind of contour, okay, using foam board, wood rock, some soft material. But in this case, of course, here are some soft material like wood rock, foam board, but all these are MDF, wood, cut by lasers, okay, laser cut produced material. And take a look, some tree structure and more structure. And take a look, transparent plastic board used for representing elevation. Take a look. Even without this plastic, you can see the elevation section, okay, the markup model. But thanks to this plastic, transparent plastic, designers can put some fonts, okay, some handwriting fonts and some illustration and dimension, some explanation and some handmade looking representation. I think it's very informative explanation as well as very visually effective, okay? Also the angle for this one can be added. So this kind of visualization, representation in actual design exhibit is very encouraging. Lots of acrylic, plastic cut by laser or some other structure also visualized here. And take a look. You can buy those people. And also you can print those people structure using 3D printers, okay? And more examples. Take a look. Created by laser cut. Take a look. Only this part printed out by 3D printer, okay? But this one, this printout, unfortunately, the owner of this one didn't know we have 3D printers. So she paid money for printing this out, $100, okay, for this one single piece, okay? That's the usual price, very expensive, crazy. Use our machines, okay? Very cheap and straightforward. You can use anytime. Anyway, some more examples, cases, pictures. And most of those markup models as well as design representations submitted to design competition. And they are mostly award-winning works, okay? Take a look. The structure here all produced by laser cut as well as 3D printing, okay? In order to make them by hand based upon some computer manufactured, computer controlled approaches, okay? And the concept is storage for this one, and this booth also used the real structure from the storage, okay? Something like this, objects. Some concept representation in the markup model and so on. Okay, here I quickly show you, review you what we have done, okay? Your senior students have done last time. Let's take a look digital design and presentation examples at this time using Idea Design Book published by ANC Publishing. Okay, let's take a look. What is this book? Actually, in professional design books such as BOB or lots of interior design or architectural design books, they are mostly real-world project-based representation. There are a bunch of pictures. For example, your final project subject, all they realized already in real world, somewhere in the world, okay? I gave you your target subject, total 10 projects. But this kind of book, idea book, sometimes even professional architect firms, their designs, just designs, okay? Not going to be realized in real world sometimes. So such designs couldn't be demolished, okay? They should be published for someone like us, okay? Someone's seeking good design visualization and good design representation. So among this book content, take a look. This is the contents. The contents of this book categorized by geometrical shape. The first one is tower and group. Tower and group category, which means building shape is looking like tower and group, which means high-rise buildings, okay? And under the box shape simply means box shape, modernism style, very efficiently designed building shapes. And polygon, some line stroke and polyline based design, and also circle or sphere, okay, circular and spherical design, as well as at the end the last one, organic form, so-called free form, okay. So let's quickly take a look at some examples. The first one, tenacity. When you see this 3D visualization, okay, actually we reviewed this one before, some of them, but take a look again. Let's take a look again. Take a look. What's the meaning of tenacity? Okay, the lower part buildings are all in brown color, which means existing buildings. And take a look, some silver and some bluish colors, structure connected each other on top of existing buildings. This 3D visualization is effective. You can find out the perspective, but it's not good before you see this kind of sketch diagram or take a look, this kind of site plan. Take a look this site plan. This is some part of Manhattan, okay? In Manhattan, there are a bunch of existing buildings like this style, okay? But they connected using some ceiling structure like this way. Take a look, white colored structure. Here, all are the structure represented in this shape, okay? They are connected, and interior of this structure probably filled with some special components and so on. I skipped some detailed pictures or some detailed text, okay? Instead, I like to show you the major feature of the concept, okay? What's the major concept? What's the major feature of this design? That's the reason why I show you those series of images. Next one, digital university. Let's take a look. Why the title for this one is Digital Studio? And take a look this building. Okay, this one is university building. Okay, that's fine. Why it's digital? It's not easy to figure out, but take a look. This concept diagram explains you one rectangle shape has some separate individual functionality spaces. Sometimes it's CPU computing, sometimes energy storage, sometimes thermal exchange system, and clean water reservoir, and so on. Which means one single dot, one single box here means pixel, okay? But it's not 2D, it's 3D. In 3D, pixel is voxel, okay? V, voxel. So that's why the title for this one is digital, okay? So this concept easily and straightforward represented thanks to this concept diagram. Take a look. All those individual pictures, renderings, all generated by computer tools and composed by this kind of additional layout and some concept diagram making purposed visualization. Next one, Ideal Tower. Let's take a look. It's looking like a high-rise building, but it's not easy to figure out the interior shape or why this geometric shape could be established before taking this diagram picture. Let's take a look. Typical urban buildings, okay? But one is going up and 90-degree rotated and distorted. And then we can get this kind of shape. Take a look, elevations. According to the elevation illustration diagram, there are no elevators, no stairs, okay? This is city farming. You know what is city farming? Even if in the city, in the middle of gray concrete buildings, we can build green farming area, okay? Inside of the building, So the concept for this one is city farming. Ideal Tower realized the city farming approach using this kind of structure, as well as the form making approach represented by this diagram. At the end, 3D render can be represented in this way. Also, next case, skyscraper city. Let's take a look. You know what is skyscraper? Skyscraper usually means this kind of elevation of city, okay? High-rise buildings elevation. This is skyscraper, okay? In Korean, Machonru, okay? But there is a balloon. Because of this balloon, it's empowered and bended like this. So that's why you can get this kind of shape, okay? Take a look in 3D. That's the original shape, but because of this transforming external power, this one is going to be bended and 90 degree. At the end, take a look. Geometric shape for this one, skyscraper city, at the end created, okay? Now the shape for this one explained by this diagram. So simply say, this one or this one, transformation concept diagram is very straightforward and very useful. In other words, visually effective, okay? That's the point. How about this one, a mosque for all? Mosque is religional space. Take a look. Thanks to this space, lots of people, in other words, some type of crowd can be they use this type of space, usually regarded as outside of the building, but they probably feel inside of the building, okay? Simply because, okay, let's take a look at this 2D diagram. This 2D diagram is very easy to draw and very simple. First one, rectangle plus diagonal shape create this type of geometric shape. But this one explains almost everything for this design and very unique, very apparently different approach to this building shape. Take a look. This is conventional mosque design. Building and exterior building, they should be getting to the building inside, okay? But take a look. What if the building is going to be flipped, okay? Inverted. And then take a look. These people, this group of people, okay, crowd may feel this is inside of the building, so-called the mosque, religional space, but physically it's not the inside of the building. Take a look this area, this space, okay? So this 2D flipped black and white diagram simply explains almost everything, entire structure of the concept for this building, okay? Very powerful. How about this one, National Art Museum of China? The reason for bringing this one is this one, okay? Take a look. This section program means special program diagram using section, okay? So you know this building simply means this structure, okay? This one is art museum. So how this building going to be composed of lots of interior spaces? Take a look. Collection, exhibition, sky garden, and bookshop, lobby. Take a look. Typography with elevation representation on this kind of very colorful color schemes, okay? So there is no boundary between architectural section drawing and typography-based 2D illustration, okay? So this single section program illustration also explains lots of things, okay? As well as this kind of 3D representation, this type of 2D representation also really powerful and effective visualization for this design. How about this one? Instant eye house. As you know, thanks to the people, you can measure the scale. Okay, this one is looking like some type of future house, future building. But it's, of course, it's not easy to figure out inside of this structure or some mechanism for the structure of this building. But take a look. Transportation diagram, elements diagram, they explain the main structure for this one, or as well as space program. They are looking some hand drawing sketch, but actually you can make this kind of visualizations using 3D representation as well as some sketch style visualization as well as some additional Photoshop retouch and so on. Okay, very effective visualization transported by trucks, and then you can install sub-components. Okay, component by component, stacked components. Take a look. Entrance, kitchen, bathroom, living room, and another bedroom can be installed using various different types like this way. Okay, so sometimes this kind of hand drawing looking representation much effective, much better than photorealistic rendering. Of course, this is not that realistic. This is not 100% photorealistic rendering. This is architectural rendering, but visualizations have their own objective. Okay, this one easily displays the external view of this structure, but this kind of representation explains a lot more, not geometric shapes, their process, their installation process, their elements, interior structure, how they constructed, how interact with environments. Take a look. Sun is here and solar panel provides electricity to heat or cool down this interior structure and so on. So this kind of visualization also very useful, and you have to refer to when you develop your own design visualization. That's the point, okay? Okay, let's see some more cases, final project development examples. I like to bring your attention using those two emphasis, okay? Firstly, try to reveal the design concept, okay? You have to find out your design concept and maximize your design concept, okay? Maximize your visual effect from your design, okay? That's exactly what you need to do at the beginning of the project. How to reveal the design concept? How to maximize, if your design is Apple, you have to display or you have to put another or a series of emphasis on apples, okay? So to reveal the design concept is the first, and next important thing is to visualize the scene. To visualize the scenes, okay, this one is an extension of this one, as well as your design representation and visualization. Sometimes you are sticking to photorealistic rendering, but photorealistic rendering is just one type of visualizations. Architecturally effective rendering, sometimes hidden line removal, okay? Just black and white line drawing. Sometimes it's very effective. So you have to keep trying visualizations in your design concept and design development, okay? And the final design effect, simply say, visually effective designs, okay? Something cool, something beautiful in terms of aesthetics. You have to find out which one is better than others. You have to choose the best one. This page is just one single page, but this one explains you almost everything about the final project development. how to represent your design. In this case, in this semester, not your design, okay? Someone's design, some professional's design. In other words, good design already realized in real world. Based upon that existing design, you have to develop your own design development material. This single slide explains you almost everything what you have to do for the final. Firstly, review your given images I gave you, okay? You got at least four or at most 8 pages, okay? 8 pages of images, okay? So you already got such kind of existing designs. So you have to find out the concept first, okay? And for figuring out the concept, capture the most important features and the concepts, you need more references, okay? Thankfully, you know the designer's name and the physical sites. You know how to survey, how to make some research on existing design. That's why I put this phrase, search more information using Google, okay? And then you can get lots of references first, okay? Images, sometimes CAD files, sometimes some vector line drawings, sometimes some textual information. And then try to capture the most important feature, the most important concept, the most important design aspect, okay? Something different from conventional, something different from general issues of design. And keep focusing on the features you captured, okay? And then modeling specific parts. I'm not talking about you have to 100% reproduce your structure, your design using 3D tools. You can focus on some selective parts, okay? And then try to render specific scenes, okay? Render here means not just V-ray render, line stroke, X-ray view, sketch style, just color scheme, lots of visually effective styles you can find out. Capture specific views and styles, okay? After that, using some After Effects tools such as Photoshop, PowerPoint, Press, and so on, you know how to maximize visual effect using grid layout system, freeform or freestyle layout system, as well as some typography, the beauty of void, and so on, what you have learned in this semester from the course, okay? And you can maximize the meaning of design you developed from existing design. So let's take a look some easy cases, okay? The first one, Hotel Expo. This one is not the subject for your final this semester, but formally this one used. GC Museum and Sleepbox. So how to capture the main aspect of design features from those given clues, okay? Just single images or elevation images for this one. Wood structure, and various kinds of chairs. And then take a look, this one. Capture the key design features, wood structures on this corner, usually for the reception area, okay, in this lobby. And take a look. Geometrically modeled ceiling structure, floor material, as well as the given furniture. They can be downloaded, but take a look. Any single chair, same, okay? They are all totally different. Some interior foliage wood structure and tables, some downloaded lighting system. Keep focusing on some major design feature that the designer, the student, captured from this one. For Jewish museum, as you see, angled walls, okay? Some angled walls and their material. Carefully assigned, modeled, even interior and exterior floor structure, as well as ceiling structure. Take a look. The ceiling structure and the translucent ceiling like this. Take a look. The ceiling structure very unique and banded, angled wall structure with their material can be modeled and visualized by this V-Ray render with Photoshop retouch. Okay. How about this one? Slip box. Slip box. Focus on each slip box module. Probably you may know what is this. This is slip box, okay, as it literally means the smallest hotel for one person, okay. You can find out this kind of slip box brand in Tokyo or somewhere in Europe, okay, not in Korea or United States. Anyway, very cheap, and someone says it's convenient, except some people. Anyway, this is one single slip box module, okay? This one can be modeled like this, very carefully, including amount of interior features, and then to put them in specific layout defined in floor plan, okay? Sometimes different floors. At the end, V-Ray visualization. Take a look. This is V-Ray visualization. This one doesn't mean it's the best output of the visualization. Sometimes V-Ray visualization is much better than regular visualization, but usually it's not true, okay? When you see just architectural line stroke is feeling better than this kind of V-Ray render, and then you have to use this kind of visualization. Or sometimes you can try to make it in black and white, okay? Not colorful render style like this, okay? And also take a look, some angles, lines I told you before, they should be perpendicular, okay? 90 degree. But this one is not. It's not a good visualization actually. But this is following that principle. So this is good visualization case. And this one also much better in terms of architectural visualization, also good visualizations. The last slide shows you the progress example. What is the progress? Let me show you this Google site example from your senior students. Okay, let's take a look this one. For the presentation, the owner of this Google site prepared a series of this slide. Let's take a look. This is the final presentation image, okay? For developing this design, all they are pictures, but take a look what she have done for the final, okay? Capturing the specific scene, okay? Actually, the floor is really huge. Instead, she focused on this area, okay? So that's why she tried to make this kind of ceiling structure, very unique ceiling structure, as well as this wood structure like this, okay? And V-Ray render output is here, another V-Ray render, even animation. Animation created by scenes in SketchUp. What you need to do is add more scenes and export by animation. And then you can get this kind of video. That's it, okay? And take a look, 2D process. In 2D process page, take a look. AutoCAD drawings for 2D. How about 3D process? Thanks to 2D CAD file imported into SketchUp, precisely controlled scale and dimension, and then take a look, 3D modeled, okay? Step-by-step process visualized for main aspects, main geometry of this building, and then at the end, take a look. 3D model composed of the design elements, what she developed from these 3D applications. And actually a lot more progress report files here, but I think that's enough, okay? Okay, it's time to the lab exercise. Final project progress report as well as some homework, okay?